Good morning to everyone. And today we will discuss about a very important topic in computer organization and architecture in GET respective, that is parallel priority interrupt. I have already discussed in computer organizations class and computer organization architecture that about daisy chaining method, and this is another type of method, that is parallel priority interrupt, which is mainly focuses on in the GET perspective that it is very important. So what is the parallel priority interrupt? We will discuss in this class. First, that what is the parallel priority interrupt? First, you see that there is a diagram in which there is an interrupt registers. There is an interrupt register, and in this interrupt register, all the input output devices, like input output devices like disk, printer, reader, keyboard, all the input output devices are connected in this interrupt register. Okay, now you can see that the mention that disk is 0, printer is 1, reader is 2, keyboard is 3. This is mainly as priority, the number is set. The highest priority, the number is 0, and the lowest priority, the number is 3. But if we increase the number of input devices, then the number will be increased. Like if we use 5 input devices, then it will be 0, 1, 2, 3, 4. And if we use 6 input output devices, then it will be 0, 1, 2, 3, 4, 5. But the lowest, in last, there is the lowest priority. Means that the keyboard here, the keyboard is least priority and disk is the highest priority. Always the highest priority it will be mentioned in first, and the lowest priority it will be mentioned in last. So here we are using 4 input output devices, and these 4 input output devices are connected to interrupt register. And here in our 4 input, among 4 input output devices, disk has the sorry, disk has the highest priority and keyboard has the lowest priority. So disk is mentioned as 0 and keyboard is mentioned as 3. Okay, now the input output devices which generate interrupt makes input register value to 1. Now those input output devices which generated the interrupt, its output will be 1. Here the output will be here the output will be 1. If all the input output devices generate interrupt, then its output will be, then the interrupt register output will be 1. And the mask register, which value is which output, the input output now the 1 goes to, and now this one goes to as an input of an AND gate, and the other value is come from the mask register. Okay, then other value is goes from mask register. The marks value sent, and this value marks value is sent to AND gate. Now at initially the mask register's value is 1. So initially all the marks register value is 1, and it is sent to the AND gate. So in AND gate the operation will be 1 and 1. The operation will be 1 and 1, and the output will be 1. Same as that in case of printer, it generated interrupt. So, and in AND gate, the value will be 1. And from initially, the mass register value is 1. So, here also, and 1. The operations output will be 1. Next, in case of reader, the in interrupt register output will be 1. And from mask register, the output will be 1. So the AND operations will be performed. So 1 into 1, the output will be 1. Same as that for keyboard. Keyboard, the input interrupt register, the output is 1, and it generated interrupt. So the input will be 1. And here from mask register, Initially the mask register value is 1, so here it will be also 1, so 1 into 1 there is 1. Now in this case, if you see that if all the input output register, all the input output, sorry, all the input output devices, if generated interrupt, then its value will be 1. So first, and from there, this one value will go to the priority encoder. This one value will go to the input priority encoder input. So the our priority encoder is 4 into 2, means there will be the priority encoder has to be 4 input and 2 output. So here all the input we have get in the priority encoder, it will be 1. Okay, so from priority encoder the output will be generated, and in this output we can get from the priority encoder the output will be generated. Okay, and here the output will be 1, but and from this priority encoder the output will be generated. This is 2 output, because we are using 4 into 2 priority encoder, means we have 4 input and 2 output. Okay, so that's why there will be 4 input and output will be 2. So in this output we, and from this output we can get the address of interrupt service routine. So then the CPU handle the interrupt. So if we briefly describe that all the briefly describe this architecture, then we'll see that first all the input output devices are connected to interrupt register, and according to their priority they are connected. The lowest priority will be at last, and the highest priority input output devices will be in first. And the output of, if any input output devices generate interrupt, its output will be 1. And initially the mask register value will be 1. So this 2 1 will go to the input as a AND gate, and their AND operations will be performed, and our desired output will be, for desired output will be generated, and this output will go to the as an input of priority encoder, and there from priority encoder the output will be generated, and we can get the address of the interrupt service routine. So now the CPU will handle the interrupt. Okay, clear how this interrupt can be handled? It is clear to everyone?
Yes, sir.
Okay, so this is all about the architecture of parallel priority interrupt. Now,
So
हाँ, okay,
जिसमें जो इंटरप्ट रजिस्टर है,
हाँ,
तो अगर सर उसमें वैल्यू 1 लेंगे तो मास्क रजिस्टर भी 1 ही लेना होगा?
नहीं, ये जो मार्क्स रजिस्टर है, मार्क्स रजिस्टर में क्या होता है, मार्क्स रजिस्टर का आउटपुट, आउटपुट नहीं मतलब इनिशियली मार्क्स रजिस्टर का वैल्यू 1 होता है, ठीक है, मतलब इनिशियली इनिशियल फेज में मार्क्स वैल्यू, मार्क्स रजिस्टर का वैल्यू 1 होता है। अब मार्क्स रजिस्टर का जो वैल्यू है वो 0 1 जो भी हो सकता है, बट इनिशियली जब फर्स्ट स्टार्ट होता है ना, तो उस टाइम क्या है, उस टाइम हम लोगों का ये वैल्यू इनिशियली 1 होता है, इसलिए इधर 1 लिए, अदरवाइज ऐसे 1 नहीं लेते, बट कि इनिशियली जो है, इनिशियली हम लोग का 1 होता है ये मास रजिस्टर वैल्यू, इसलिए ये 1 जाएगा। तो अब देखो अगर जो इनपुट आउटपुट डिवाइसेस इंटरप्ट जनरेट करेगा, इधर क्या है, फर्स्ट एज ए एग्जांपल हम ले रहे हैं कि सारा जो इनपुट आउटपुट डिवाइस है वही क्या है, इंटरप्ट जनरेट किए। तो अगर इंटरप्ट जनरेट किए मीन्स ही क्या होगा कि सबका वैल्यू 1 होगा, मतलब 1 मतलब ही कि इंटरप्ट जनरेट किया है। तो अब क्या है, देखो मार्क्स रजिस्टर के भी चारों ऐसे आउटपुट है, तो ये एंड ऑपरेशन में जाएगा एज ए इनपुट। अब ये जो एंड ऑपरेशन होगा, अब देखो 1 into 1 एंड ऑपरेशन में क्या होता है, 1 into 1, तो आउटपुट क्या होगा, आउटपुट 1। अब ये जो है प्रायोरिटी एनकोडर है, प्रायोरिटी एनकोडर क्या है, 4 into 2 प्रायोरिटी एनकोडर। तो 4 into 2 प्रायोरिटी एनकोडर में क्या होगा, 4 इनपुट होगा 2 आउटपुट होगा। अब
आउटपुट
ये
होगा।
जो है 4 हम लोगों का जो इनपुट है 4 इनपुट लेगा और आउटपुट हम लोगों का 2 आउटपुट देगा। अब ये जो आउटपुट देगा वो आउटपुट क्या होगा, इंटरप्ट सर्विस रूटीन जो है उसको हैंडल करने के लिए, मतलब सीपीयू जो में है मेनली इस एड्रेस के थ्रू इंटरप्ट को हैंडल करेगा। ठीक है, ये बेसिकली फंक्शंस है। बट अभी केसेस है कि क्या क्या हो सकते हैं। ठीक है,
तो
मतलब
इसमें
ऐसे
हाई प्रायोरिटी और लो प्रायोरिटी कैसे जज करेंगे फिर?
अभी ये जो है मतलब जिसका लोएस्ट प्रायोरिटी ये इनपुट आउटपुट डिवाइसेस के, ये इनपुट आउटपुट डिवाइसेस का जब हम डिस्कशन किए थे तब बोले कि जिसका ऐसे इनपुट आउटपुट डिवाइस है, मतलब जिसको एग्जीक्यूशंस जो है एग्जीक्यूशंस के लिए कम टाइम लगता है उसका हाईएस्ट प्रायोरिटी है। जिसका एग्जीक्यूशंस के लिए कम टाइम ज्यादा टाइम लगता है उसका लोएस्ट प्रायोरिटी है। ऐसे हम लोग डिसाइड करते हैं हाईएस्ट प्रायोरिटी लोएस्ट प्रायोरिटी
मतलब
जब हम।
टाइम को एग्जीक्यूशन को देख
हाँ, टाइम अब
के।
एग्जीक्यूशन को देख के। ठीक है,
Yes.
तो now we will discuss one by one cases that what the according to the output in all the cases. First, if all the first in cases we 1 minute. Now in first case that all the input output devices generate interrupt, means all the input output devices generate interrupt. Okay, then the interrupt register output will be 1 for all the devices. For all the devices, interrupt register output will be 1. And initially the mask register value is 1. So each, each mask register output will be 1. So AND operations will be performed. Here 1, 1. So output will be 1. Then for in this case, here also the input will be 1 and mask register from mask register the value will be 1. Then here also the input of an AND gate is 1 and other input will be 1 also. And here the from keyboard the input will be for AND gate 1 and from mask register the value will be 1. So all the AND operations will be 1. But here some cases arises. Now in our 4 into 2 priority interrupt, in our 4 into 2 priority interrupt, if the high priority input output devices generate interrupt, then we take don't care condition in case of other input devices. Means here the most highest priority devices is disk. So if disk generated interrupt and if disk generated interrupt, then we take don't care condition for other input devices. If it generate interrupt or not, we will not consider that. We will not consider that. We will only consider the highest priority interrupt which will generate the interrupt. If all the devices generate interrupt, in 4 into 2 priority encoder, we will only consider the highest priority interrupt and we will discard priority other input output devices which generate interrupt, because we only if we only consider the disk, because disk is most highest priority interrupt. So if other devices generate interrupt or not, will not consider that. We'll only consider highest priority interrupt. So मीन्स क्या है कि हम लोगों का अगर जितना इनपुट आउटपुट डिवाइसेस है जैसे डिस्क प्रिंटर रीडर कीबोर्ड, जितना मेरा इनपुट आउटपुट डिवाइसेस है, हम लोग क्या है कि अगर हर इनपुट आउटपुट डिवाइसेस हम लोग का इंटरप्ट जनरेट किए, बट we will only consider highest priority interrupt and other interrupt will be don't care condition. That's why here you can see that input at first disk generated interrupt. That's why one is considered, and in other case the input is considered as don't care condition. If it generate interrupt or not, we will not consider that. We'll only consider if all the devices generate interrupt, we will only consider the highest priorities interrupt, and others priority interrupt will be discarded. Yeah, we will consider it as a don't care condition. That's why that it is here written XXX. Clear? So in case one, if all the input output devices generate interrupt, we'll only consider highest priorities interrupt, but we will use don't care condition for other input devices if it generates interrupt or not. Okay, clear? Clear? First condition is clear. Clear for first condition.
Yes, sir.
Okay. Next, if next condition, if disk didn't generate interrupt and except disk, all other input output devices, in this example, disk didn't generate interrupt. Except disk, all the input output devices generate interrupt. Means disk output will be, disk interrupt register output will be 0. And for others, printer, reader, keyboard, all generated interrupt. That's why the interrupt register output will be 1. Now among this, printer has the, now only these 3 input output devices generate interrupt. Disk will not generate interrupt. Then among this printer, reader, keyboard, only printer has the highest priority. So in our case, we will consider printer's output. But in case of others, it is other input devices, it generate interrupt or not. Will not consider that. So in other 2 cases, there will be don't care condition. Okay. That's why here it is written I0. I0 is for what? Disk. Now in this example, I tell that disk didn't generate interrupt. That's why disk input is, disk output is 0. And I1 is related to printer. Among this, printer has the highest priority. So 1 is considered. And others, keyboard and reader, it generate interrupt or not, we will not consider that, because we always considered highest priorities interrupt. Other input devices may generate interrupt or not, we will not consider that. In that case, we will use don't care condition. In next case, case number 3, here disk and printer didn't generate interrupt. Only reader and keyboard generated interrupt. Now among reader and keyboard, reader has the highest priority. So we will consider reader interrupt, but will not consider keyboard interrupt, because we only consider the highest priorities interrupt. That's why in that case, 1 is written for reader, but with other condition, keyboard, we didn't consider it. That's why the don't care condition. And in last case here, only keyboard generated interrupt. Then that case, keyboards in the value of input, the keyboard value is 1 and others are 0. And at last, if no one generated interrupt, then in that condition, all inputs will be zeros. So this 5 condition we mentioned here, that if all input output devices generate interrupt, and if no input output devices generate interrupt, and these 3 conditions, that if among one them generated interrupt or not. These are all the input output devices generated interrupt. Based on this, the table is created. And always one thing, we have to remember that we have to consider that highest priority is interrupt. If we get the highest priority interrupt among input output devices, then others input output devices priorities, will don't consider it. We'll simply use don't care condition for that. Okay, clear?
Yes, sir.
Now this is all about parallel priority interrupt. Now I have something to mention here, that what is IST? You can see in this example there is written IST and IEN. Now IST is a flag. This flag describes this IST. Now what is this IST? IST describes any particular device generate interrupt. It uses as a flag, and this flag describes that any particular device generate interrupt or not. Means if IST value is 0, then we can say that no input output devices generate interrupt. If IST is represented as flag, its value must be 0 or 1. If its value is 0, that means no one generated interrupt. And if its value is 1, that means interrupt is generated. Now in this interrupt generated, any input output devices can generate interrupt, but IST only show that 1 means any of the input output devices generated interrupt. It doesn't particularly mention that this input output devices generate interrupt or this input output devices generate interrupt. 1 means that any of the input output devices is generated interrupt, and 0 means no input output devices has generated interrupt. IST is represented as this type of flag, which tells 0 means no one generated interrupt, and 1 means any of the particular input output devices is generated interrupt. Okay. Now another one is IEN. Another one is IEN. This is also IEN is also a flag. This describes whether CPU is ready to take interrupt or not. IEN simply describes CPU is ready to take interrupt or not. Means that CPU is ready to take interrupt. If IN is 0, that means interrupt will be handled by CPU. That any of the input output devices has generated interrupt, and now this interrupt will be handled by CPU. If IN flag value is 0, it means interrupt, sorry, IN value is 0. That means interrupt will not be handled by CPU. That means interrupt will not be handled by CPU. Sorry, 0 means interrupt will not be handled by CPU. Now CPU is not ready to take interrupt. And if IN value is 1, that means interrupt will be handled by CPU. That means interrupt will be handled by CPU. Okay, so IN is also represented as a flag. It has two output, 0 or 1. 0 means that CPU will not handle the interrupt, and 1 means CPU will handle the interrupt. Okay, so now in this case, if we see that IN and IST both have value 1, then there will be, if both have value 1, then here you see that the input will be 1. For IN and IST, both, if both value is 1, then as an AND gate, its input will be 1 into 1. So interrupt will be enabled, and interrupt will be enabled, and interrupt will also be handled by CPU. And from this, CPU will send a acknowledgement signal to the acknowledgement signal for that to enable the interrupt. Okay, so if both IN and IST value is 1, then the CPU will send in acknowledgement signal as a 1. It means that interrupt is enabled, and through particular address, the interrupt will be handled. So if both the value is 1, then the interrupt will be generated. Okay, if IN and IST, two flags, if these two flags output will be 1, then the acknowledgement signal from CPU will go to the AND gate. That means our interrupt will be enabled, and the particular address the interrupt will be handled. So that's why you see that if X and Y value is 0 and IST value is 1, means interrupt is generated. If 0 or 1, this is means also interrupt is handled. If 1 and 0, this interrupt will be handled, and if interrupt will be, if there is IST value is 0, that means we have don't care condition. Our input output device will not generate interrupt. If no interrupt is generated, that's why X and Y value is X and X, means don't care condition. Okay, clear? Clear to everyone? I will repeat it.
No, sir.
Okay. So if anyone has any question, you can ask it. Otherwise, I will move to the next topic. Now, our next topic is CISC and RISC. Now, what is CISC? CISC means complex instruction set computer. Means the instruction set which we used are complex. That's why it is complex. It is called complex instruction set computer. And RISC means reduced instruction set computer. In CISC, number of instructions are large. The instructions you have in classes, I have also tell that instructions. Computer uses instructions. So based on these instructions, it is two type. One is complex instruction set computer, that is CISC, and other is RISC, reduced instruction set computer. This is the two type. Now, in CISC, number of instructions are large. The instructions which is used in CISC are large. Whether in RISC, the number of instructions are less. Instructions are less. In CISC, variable length instructions format is used. Variable length instructions format means that their instructions, those instructions which is used, has no particularly fixed format. The instructions which is used can be of 16-bit, can be of 32-bit, can be of 64-bit. Means our length of instructions format is variable. It can be changed. That instructions can be of 16-bit, can be of 32-bit, can be of 64-bit, etc. But in case of RISC, the length of instructions format is fixed. Means if it is used 16-bit, then all over the instructions, it will be 16-bit. That is not means if 16-bit, other next instructions will be 32-bit, next instructions will be 64-bit. No variations will be there. If we use the instructions format is 16-bit, then all the instructions will be 16-bit. So that's why RISC means fixed length instructions format. But there is no such constraint for CISC. In CISC, length of instructions format is variable. Means instructions format can be different time. Now in CISC, large number of addressing mode is used. Now, large number of addressing mode is used because of here in CISC, the variable length is, it works on variable length. Because the instructions format we used in CISC are of variable length. And using variable length instruction, our addressing modes became large in CISC. But in case of RISC, the instructions format is fixed. Though the instructions format is fixed, we require few number of addressing mode. The instructions format is fixed. That's why here few number of addressing mode is required. But in case of CISC, it works on variable length. It works on variable length. So large number of addressing modes is required. Now CISC, though the large number of addressing mode is required, the cost is become also high for CISC. But in case of RISC, there is no large number of addressing mode is required and no large number of hardware and complex hardware is not required. So that's why the cost is low for RISC. Now, in case of CISC, it is more powerful. But in case of RISC, it is less powerful. In case of CISC, several cycle instructions format is required. Several cycle instructions means there is no such constraint that the instructions will be executed in one clock cycle. But in case of RISC, single cycle instructions is required. Means in pipeline, which in pipeline you have seen that cycle per instructions. We try that in first instructions it requires some time, and after that first instructions execution, we try that clock per instructions will be 1. We mainly try that the clock per instructions be 1. So we try it in RISC that RISC for instructions execution, single cycle instructions is required. That means our CPI must be 1. But in CISC, there is no such constraints. Here, several cycle instructions can be used. Several cycle instructions can be used. So here, the clock per instructions is much more. But in case of RISC, here is single cycle instructions. So mainly in pipelining, we use single cycle instructions. So we try that in RISC, our clock per instructions became 1. In RISC, mainly the manipulation directly works in memory. In memory, all the instructions manipulations are worked. But in case of RISC, we use registers. And in CISC is based on microprogram control unit based, whereas in RISC it is hardware control unit based. Now, if we see through an example, it will be also cleared that if there is a memory, like this is a memory, and this memory, there is two value X and Y. Now you see that X is stored in 2x2 memory location and Y is stored in 3x3 memory location. Okay. So in CISC, if we execute this X and Y, then what will be the instructions format? Mainly CISC is used for mainframes computers, Motorola 6800, Intel 800. This type of frames we use CISC, but means complex instruction set computer. Now, if we try to do some operations, like in this memory unit, X is stored in 2x2 memory location and Y is stored in 3x3 memory location. So if we try to execute this instructions format, then we use like mult. Mult, this is an operation for multiplication. Mult 2 is to 2, comma 3 is to 3. Means here 2 cross 2 x value is stored. So here x will be used, and in 3 cross 3 y will be used. So after multiplication, the value will be stored in x. So here you can see in complex instruction, totally less number of instructions we execute that. But to execute this, we require more complex hardware. In case of CISC, our hardware is more complex. Like you have seen this, that instructions format is easy, but behind this, there is more complex hardware required. But in case of RISC, the instructions format is fixed. So RISC is used by MIPS, ARM, Spark, Fugaku. This is new computer, new ready-made computer. This used this type of RISC instructions format, means reduced instructions format. Now, like this, if we want to execute that, we have to first load a comma 2 is to 2. If we used this example, try to execute this example in reduced instruction set computer, then the instructions format became large. Now you see that first we have to load 2 cross 2 value into register A. Now if you see clearly that in CISC there is no registers mentioned. There is no registers mentioned in CISC, but in RISC, because CISC, I have already explained, CISC mainly data manipulation, mainly manipulation directly in memory. So it is mainly memory based. But in reduced instruction set, we have to use registers. We have to registers. That's why in case of executions of this, the registers are register set used for reduced instruction set computer for executing this example. So first we have to load this x, means this x, the memory location of this x, 2 cross 2. So 2 cross 2 into A, means RA register. The value that is stored in 2 cross 2 memory